All right, welcome back. In this video, I'm going to be telling you about the product and quotient rules. And to start, I'm going to ask you a question. Do you think that we can take the derivative of a product by just multiplying the derivative of each of the factors? So, like, my question is f of x, or is f prime of x equal to the derivative of 2x plus 3 times the derivative of x minus 4? And the answer is no, right? That seems too good to be true, and it definitely is. I think the first reason you can see is that 2x plus 3 times x minus 4 is going to be a second-degree polynomial. Its graph is going to be a parabola. And we could expand it, like this with 2x squared minus 5x minus 12 using the distributive property. And then I can take the derivative of f using the power rule, right, that we learned last time. So that'll be 4x to the first minus 5, and then the derivative of negative 12 is going to be 0. And we can see that that is not the same as 2 times 1. And this is the product rule. So showing us how to take the derivative of two functions multiplied by each other. This does not nullify what I had said before about the derivative of a number times a function. This is for two functions that involve x, right? So I'm saying that this is how we take the derivative of a product. Okay, so what we do is we take the derivative of one while leaving the other one the same. And then, to be fair, we add in taking the derivative of the other one while leaving the one the same. Okay, and that's the product rule. So I'm going to leave that up there, and I'm going to work some examples. Let's start with a nice little product, and we want to write the equation of the normal line. And remember, the normal line is perpendicular to the tangent line at the point of tangency. So I'm going to need a point. Maybe I'll switch up the color. I need a point, and that will be where x is 1, and y is equal to 1 times e to the 1. Well, 1 times e to the 1, that's just e. So I'm going to just say that's e. Okay? The slope of the normal line is going to be perpendicular to dy dx, which is the slope of the tangent line. And so we need to take dy dx. Okay, so if y is x e to the x, okay, I take the derivative of the first item, that's x, and so it's going to be 1. And I'll leave e to the x the same. Then I add in, leaving x the same. I'm going to take the derivative of e to the x, and that's going to be e to the x. Okay. And it doesn't matter if I do, f prime g plus g prime f, or if I add them in the opposite order, if I multiply them in the opposite order. These are real numbers, and we know that multiplication and addition of real numbers, it commutes just like we would hope. Okay, so this is equal to e to the x plus x e to the x. And maybe I'll write that since I started with x. X e to the x plus e to the x, plus 1 e to the x, right? Okay, so dy dx at the point where x equals 1 is going to be equal to 1 e to the 1 plus another e to the 1 is 2 e to the 1. Okay, meaning, I'm going to hide the product rule for just a moment. We did our derivative step, so now this is just other calculus. So perpendicular to slope to 2e over 1 is negative 1 divided by 2e. So that's going to be my slope, and I can now write in my equation. I'm going to say y minus the y coordinate, the point we know on the line, is equal to the slope times x minus the x coordinate, the point we know on the line. Next, I've got a table problem for you. Okay, these table problems are really common in AP Calculus, or the graph problems, and maybe I'll have some of those coming up later. Okay, so h of x is x squared times f of x, find h prime of 5. Okay. Well, first we're going to need to find h prime of x before we can find h prime of 5. So h prime of x, I'm going to use the product rule because I'm dealing with a product right here. So this is going to be the derivative of x squared, leave f of x the same, then add in, leaving x squared the same, taking the derivative of f. Okay. Then I'm going to plug in 5 for x. Okay, so that's going to be 2 times 5 is 10 times f of 5, plus 5 is 25 times f prime of 5. And this is going to be 10 times f prime of 5 is negative 1. plus 25 times f prime of 5. Hold on, what did I just do? F of 5 is 4. F prime is negative 1, so that's going to go right here. Okay, yeah, so that's 40 minus 25 is 15. Now let's get some algebraic examples. I think that's going to be something that you're going to need to practice. I know there's a lot of these on the homework, so I'll give you plenty of opportunities to get your practice in on this. I think these, at least the first two, are two that I want you to try on your own. So you should pause the video, because in 5 seconds or so the answer is just going to just pop up. All right, there you go. There's the first two. So the first one, we have to remember that we need to always write a square root as a 1/2 power and use the power rule. Okay, so I take the derivative of x to the 1/2 power, I get 1/2 x to the negative half, and I leave cosine the same, then I add in, leaving x to the 1/2 the same, the derivative of cosine is negative sine, that's where that minus came from. Then over here on the right, it's okay, I take the derivative of 2x to the 3, and I get 6x to the 2, leave log the same. Then I add in, leaving 2x to the 3 the same, the derivative of natural log x, which is 1 over x. Okay, and you could simplify that and make it 2x squared in that second term if you wanted. You could factor it, but this is all just as correct. Okay. The third and fourth ones, okay, this is just a little different, so I figured I'd do it myself for you. Find dy dx, and I was calling it y prime. Same thing, all right? Doesn't matter. Dy dx is I'm going to take the derivative of 3x and leave f the same. Then I'm going to add in, leaving 3x the same, taking the derivative of f, which is just going to be f prime. Now this last one here, we're going to need to rewrite this. Okay, rewrite sine squared x as a product, right? This is sine x times sine x. So when I take the derivative, I'm going to take the derivative of this one, and that's cosine x, and leave sine x the same. Barely still in the shot. Okay, then plus taking the derivative of this one, that's going to be cosine x, and leaving the first one the same. And we could add that together and make it 2 sine x cosine x, which if you remember your trig engine is the same as sine of 2x. That's not important here. But I think I'll just leave it there for now, and I'll come back to sine squared x in the next video when we talk about chain. Okay, let's talk about the quotient rule. Now the quotient rule, a lot of times people are going, or you'll see it in the textbook written as the derivative of f of x divided by g of x. But I'll be honest with you, I don't want you to remember this in terms of f and g, because on the AP exam or on the quiz or the test or whatever, invariably I'm going to ask you about g divided by f, just to make sure you're not just like, mindlessly memorizing a formula in terms of f and g and primes and stuff. So I write it in terms of top and bottom. So the derivative of the fraction with the top and bottom is bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, and you're going to need to write that down a bunch of times, say it out loud a bunch of times, just so that you can remember it. But the best way to remember it overall is just going to be by working a bunch of examples. So let's get to work. All right, we can start with a table problem again. So p of x is g of x divided by f of x, just like I told you I was going to do. I'm going to start with it now. So I'm going to need, and there's no real prompt here. I think it's find p prime of 1. It's about all we can do right now. So what I'm going to do is I'm going to say p prime of x is equal to bottom derivative of top minus top derivative of bottom divided by bottom squared. All right. Then what I'm going to do is I'm going to just, wherever I see x, I'm going to plug in, whoops, that's not working as well as I'd hoped. Wherever I see x, I'm going to plug in 1, right? F of 1, g prime of 1, g of 1, f prime of 1, and f of 1 squared. And I can look all these numbers up off the table. So f is negative 2, g prime is 20, minus g is 4, times f prime is 5 divided by f squared. Well, f is negative 2. So I might just write it like that and just move on, right? Because that's a number that's equivalent to the derivative of p at x equals 1. Right, now this one is one that was on a recent AP exam that I graded for over the summer, and this derivative was not highly scored on, and I have a feeling that whoever wrote this question kind of expected that to be the easy part of the question using the quotient rule. But man, people ran into problems on this. So I figured this would be a good example for us when we're first learning the quotient rule, right? So f prime of x is going to equal bottom times the derivative of the top. Well, the derivative of the top, the derivative of 1 is 0, minus the derivative of natural log of x is 1 over x. Okay? Minus the top times the derivative of the bottom, and the derivative of x is 1, divided by the bottom squared. Now, I think on the problem that I graded, you actually had to maybe find f prime of like e or something. I don't really remember, but I don't think that, I think they had to do something further with it. So what I'm going to do is I'm going to say x times 1, negative 1 over x is negative 1, and then minus another 1 minus plus log x, right, divided by x squared. And we could add these two negative 1s together and get negative 2, and then I'd have myself a nice looking derivative for f. Now we've done some quotient rule examples. Let me tell you about some new derivative rules for you. Okay, I'm going to tell you about the derivative of tangent x and secant x, and then I'll tell you you'll take the exact same process to find the derivatives of cotangent and cosecant, and I'm going to ask you to do that on the homework. Okay, and I'm just going to tell you right now that the derivative of tangent is secant squared x, and that's going to be a formula you're going to have to know in this class. Okay, the derivative of cotangent, that's less important. Okay, that doesn't come up as often, but the derivative of tangent comes up often enough that you just need to know it in AP Calculus. Okay, but I don't want to just throw this formula at you with no reason to believe me. And while I'm on that topic, I did throw the product and quotient rules at you with no reason for you to believe me, but I do have proofs of those available on my YouTube channel. So I'm going to just link those proofs in the description of this video, and you can just see this down below. Okay. But this is easy enough that I can just show you why this is true right now. So what I'm going to do is I'm going to take the derivative of tangent, except I'm going to write tangent as sine of x divided by cosine x. Okay. And so I'm going to use the brand new quotient rule I've got. So it's bottom times the derivative of the top minus the top times the derivative of the bottom. Wait, no. Bottom times the derivative of the top. What have I done? Yeah. Hold on. I was saying it, but I wasn't doing it. The derivative of the top is the derivative of sine, which is cosine, minus the top times the derivative of the bottom, and the derivative of cosine is negative sine, divided by the bottom squared. Okay, well, if I have two negatives, that's going to be positive. So I have cosine squared x plus sine squared x, and hopefully that sets off a little alarm bell in your head. And this is, on top, this is 1. And on the bottom I have cosine squared x, and we know 1 over cosine x is secant x. So it stands to reason that 1 over cosine squared x is going to be secant squared x. Next, I'm going to explain to you why the derivative of secant is secant tangent. And now, I think a question I took in class when I was delivering this lesson was that, hey, do we need to know those trig identities? And I would not say that you ever need to know it to solve any of the problems. It can just help with situations like these. Okay, so the derivative of secant is secant tangent. I'm going to show you that. And I'm going to start by writing secant as a fraction and using the quotient rule. So it's going to be 1 over cosine x. Okay. And so for cotangent, you do the exact same thing I just did for tangent, except instead of writing it as sine over cosine, you'll write it as cosine over sine. And it'll still use the exact same steps. So this is bottom times the derivative of the top, and the derivative of 1 is 0, minus the top times the derivative of the bottom. Wait, that's negative sine x divided by the bottom squared. So that's cosine squared x. Okay, this is 0 plus sine x. It's 1 power of sine on top and 2 powers of cosine on bottom. So this is like 1 over cosine x multiplied by sine x over cosine x. 1 over cosine is secant. Sine x over cosine x is tangent. Okay, so that's 2 of the formulas. I would say you can just go and investigate the other 2 on your own, but you need to know all 4 for this class. Okay, another algebraic example here. I've got a quotient. What is the value of f's derivative at x equals 1? What is the instantaneous rate of change of f with respect to x at the point where x equals 1? So we're going to need to use the quotient rule. So I'm going to start by taking the derivative of f, and that's going to be bottom. Derivative of top is going to be 2x minus 0 minus the top times the derivative of the bottom is 2x divided by the bottom squared. So it's x squared plus 1 squared. Okay? And I'm going to just clean this up a little bit. Although, if you didn't actually know, why would I do that? I only care about f prime of 1. I'm not interested in like the horizontal tangents or anything. So I'm directly in with 1, and I'm going to get 1 plus 1 is 2 times 2x is 2 minus x squared minus 4 is 1 minus 4. It feels like negative 3. 2x is 2 divided by x squared plus 1. We already found that to be 2, and we're going to square it. And that's a perfectly good place to stop. If you wanted to, you could take it farther and say that's 4 plus 6 is 10 divided by 4 is 10 divided by 4. All right, here's another more algebraic quotient rule example that I think I'd like for you to try on your own. Okay, so what you should do, again, like I've said before, you should pause the video, work it yourself, and check your work against mine. All right, there you go. Now, if a person wanted to, they could certainly say that this is 2x times cosine of x plus x squared times the sine of x divided by cosine squared x. But they'd be no more right than somebody that stopped at the first line in blue. All right, now I've got a horizontal tangent question, and so remember that when they ask about horizontal tangents, that is where the slope is 0. Okay. So I'm going to take the derivative, and I'm going to set it equals 0 and hopefully solve. All right, so what I'm going to do, I'm going to take this, and I'm going to take the derivative of it. Now, maybe I don't need an arrow that far. Maybe I'll just go here and say dy dx is equal to bottom derivative of top minus top derivative of bottom divided by bottom squared. Okay. If I'm interested in where this type of object equals 0, I'm probably going to need to just move this. Right. And I'm interested in this equaling 0. Well, the only time that that's going to equal 0 is when the numerator is going to equal 0. Anytime where the denominator does equal 0 is a place where the denominator of the original function equals 0, and that function is not even defined, so how are you going to lay in a tangent line somewhere where the function is not defined? Doesn't make sense. So I just need the top to equal 0. So that's going to be, or you could, if that wasn't all right with you, turn that into a fraction and cross multiply, and then you'll see that you just need the top to equal 0. So I'm going to distribute, and I'm going to have 2x squared minus 2x when I distribute here and there, minus an x squared equaling 0. Yeah, so that gives me x squared minus 2x equals 0, giving me x times x minus 2 equals 0, and that happens only when x is equal to 0 or when x is equal to 2. Right. All right, now the last thing I've got for you is kind of a set of drill problems that you can't see yet. There they are. So I want you to take the derivatives of these and, get yourself some practice, and then you can check your work against mine, and I will put the answers up in, 5 seconds. Okay, here you go. So I just applied the quotient rule 3 times. I think on the first one, the most interesting thing was you just need to remember that the derivative of tangent x is secant squared x. On the second one, okay, just like always, we need to rewrite a square root as a 1/2 power, and then after that it ended up being the same. You see I didn't simplify, and I don't expect you to either necessarily. Then on the third one, one thing I do want to point out before I let you go here is that e to the x squared, this is equal to e to the 2x, which is not the same as e to the x squared. Like squaring x and then putting that as the exponent of e, these are different things, okay? So I just want to remind you of that exponent rule. But yeah, that's all. Just really at this point, what you need to do is practice your product and quotient rules. You need to do them both 100 times, and then it will become second nature.